Bismillah. Let's start P3. In fact, the variant 3.2 of this pure mathematics 3. And this is June 2020 paper. Okay, it says find the quotient and remainder when all of this is divided by this. Okay, so you need the quotient and the remainder. So I think it's better if we directly go for the long division. Yes. Otherwise, I think we can factorize this as well, and yeah, that would be longer. So let's straight away go for the long division over here. Okay. So here we are. So this goes inside here. This is the dividend. 6x is per 4 plus x cube minus x square plus 5x minus 6. And here is the divisor, which is 2x square minus x plus 1. So you have to see that all of these two polynomials, they should be in descending order with respect to their powers. Yes, they are. And then now you just look at the first uh, term here, the leading term, 2x squared, and then look at this 6x is per 4. You have to see this into what will give you 6x is per 4. So that is clearly 3x squared. So 3x squared into 2x squared will give you 6x raised to the power 4. 3x squared into minus x will give you minus 3x cubed. And then this is plus 3x squared. And then we have to subtract all of them. Okay, so we change the signs to show that subtraction taking place here. So you have 4x cubed and minus 4x squared plus 5x minus 6. Okay, now this 2x squared into this, into what will give us 4x cubed. So that is going to be plus 2x. Okay, so 2x into 2x squared gives us 4x cubed. This one is minus 2x squared. And then you have plus 2x. So we change the signs because we are subtracting these. Okay, so this is minus 2x squared plus 3x minus 6. Okay, now 2x squared into minus 1 can give us minus 2x squared. Okay, so this is minus 2x squared plus x, then minus 1. And then we subtract them. Okay, so this is this, and this. So here we are, this is 2x minus 5. So the quotient is 3x squared plus 2x minus 1, and the remainder is 2x minus 5. You can also write that all of this divided by this. If this is your f of x, suppose this is your g of x. So f of x divided by this g of x is going to be the quotient 3x squared plus 2x minus 1 plus the remainder over the divisor. So this is also the way of writing this. Okay, as you write, for example, if you divide 7 by 2, just 2 3s are 6, you subtract, you get 1. Okay, so this 7 over 2 is 3 whole 1 over 2, which is same as 3 plus 1 by 2. Okay, so this is the first question that we complete. If there is any question, I would love to hear that. Okay, so there's no question. So I scroll this up to the next question. So here is this. Oh, now this question is from the linear log. Okay, normally we do not pay so much attention onto it because this is not directly, this doesn't look like directly to be a part of your syllabus, because this is an extension of your chapter on logarithms plus your chapter on the coordinate geometry, where you learn how to write the equation of a line. So let me give you a quick recap of this so that you can understand what is going to happen here. Guys, whatever the equation you have to write that equation in the form y is equal to mx plus c. Okay, so for example, you have there is an equation y is equal to x squared plus 1. Okay, and suppose I'm giving you a quick recap for this. Okay, suppose you have x and y, like when you put x as 0, y is 1. When you put x as 1, y is going to be 2. When you put x as 2, y is going to be 5. When you put your x as 3, your y is going to be 10. Okay, now this would clearly be a curve like this. Okay, like you have 0 comma 1, 1 comma 2. Okay, and you have 2 comma 5, then you have 3 comma 10. So this would be a curve going up like this. Okay, if you, instead of you assume that this x square is your x over here, and you assume that this is going to be y is equal to x plus 1, you square all the terms of x, x is going to be x squared, like your x is going to be 0, 1, 4, and 9. Okay, and then you keep y as it is, that is going to be 1, sorry, this is your y, this is 1, 2, 5, and then 10. Now you see, if you like plot them here, this is 0, 1, 1, 2, and then you have 2, 3, 4, and then 1, 2, 3, 4, 5. So you will be obtaining a line graph. Okay, so this is basically done to convert any given kind of a function into a linear function. Okay, so now look at this. You have been shown ln y over here. Okay, this ln y is basically your capital Y. So this equation is y is equal to mx plus c. Okay, so now, how did we get this equation? Let me tell you. Now, this was your original equation, y squared, that is equal to ae raised to power kx. If you look at this equation, guys, this equation has got only two terms. One is y squared, the other is ae raised to power kx. And we have to write this in this form, like, there have to be three terms where one is purely a variable, other is purely a constant, and then there is a constant of the variable and the constant. Okay, I mean, there's a combination of the variable and the constant. If you look at this, we just have two terms over here. So it's a logarithm that would come to help us, to save us. So if you take the logarithm on both the sides, you will be able to split these, like, this product over here, because, your ln AB is same as ln A plus this ln B. Okay, so if I apply ln on both sides, so you see, what do I get here? This would be 2 ln y, that is equal to ln A plus ln e raised to power kx. So this becomes 2 ln y, that is ln A, and then this is kx ln e. And you know that ln e is 1. So this is 2 ln y, and I'm just going to write it as kx plus ln A. And let's divide both the sides by 2 over here, so that you have ln y over here. This is your ln y, that is going to be k over 2x, and this is plus ln A. Now, guys, this one is going to be your y. Okay, you will take, if for example you had the values of y, and then you had to find the ln of all those values over here, so that you can plot them as I plotted. This was like, x was x squared over here. So this x square value against y, this resulted into a linear graph here. Okay, so this is going to be y, and then this k over 2 is your gradient. Okay, mx, and then this whole ln A is your c. Okay, so it says find the value of values of A and K correct to two decimal places. So this means that, like, we have plotted L and Y over here. We have plotted X over here. So this L and Y is your Y over here. And that is why you have a straight line graph. The gradient of these 2 points over here will give you the value of K over 2. The gradient, for example, if like, suppose I ask you to write down the equation of a line which is passing through these 2 points. So you would say, okay, sir, no problem. I have Y is equal to mx plus c situation here. So the gradient would be y2 minus y1 over x2 minus x1. Okay, so let's find that. This is going to be 2.7 minus 1.2 and then divided by 5.24 minus 1.5. So you see, this is 0.40, or if I, let me write that exactly for a moment. So this is 75 over 187. Now see, this m is basically representing this k over 2. So we can say, yes, we got this k. So this k over 2 is going to be all of the 75 over 187. So therefore your k would be 2 into this 75 over 187. So this is times 2. So here is your k. That is, it says write your answer correct to two decimal places. So this is going to be 0.80. Okay. If I'll be writing it as 0.8021, and then finally I can say, okay, my k is going to be 0.80 correct to two decimal places here. Okay, and then we have to find the value of a over here. So now this equation has become y is equal to 75 over, try to keep the exact values here, okay, plus c. So if we put another point over here, we can get our c over here, okay. So let's use this point here. So this will give you, let me erase all of this from here so that I can do some working in this area. Okay, so yes. So we have here y is 1.2, that is equal to 75 over 187 times 1.5, and that is plus c. So your c is 1.2 minus all this. Okay, let me see, this is 75 times 1.5 and then divided by 187. Okay, this, and then we have 1.2 minus this answer. So yeah, we have this c, so this blah blah blah. So we have c equal to, I'm again going to write its exact value, okay, because I still have to write, take its logarithm here. So this is 1119 over 1870. Now this c is, you can see that this is your ln a. So this ln a is going to be equal to this over 1870. Therefore, your A is going to be ln inverse of this 1119 over 1870. Therefore, A is going to be finally, now shift ln of the answer. So that is 1.82, correct to one decimal places. That is your 1.82. So that is how you will be able to find the values of this A and K from here. So we have basically tried to go over the topic which is called the linear law. And believe me, you need to do some more questions on it because this question rarely appears in the past papers. So in every 10 years, you might see once or twice this question coming. So might be this year you might not see this question in your exam. Anyhow, let's move on to the next question then. Um, okay, so I move on to question number 3. Okay, here is the third question. Okay, he's going to test our skills on the integration by parts. Hai. So you see there's clearly a product. Now this is something alarming over here. This is really dangerous because If you again go through your past papers, whenever there is a question to be integrated by parts or by substitution, the examiner would say that, okay, apply integration by parts to find blah, 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 or apply integration by substitution to blah, blah, blah. But here you see, nothing has been, there's no clue. He has just given you, he's asking you to find the exact value. So guys, you need to be really good at your integration techniques, okay? So this is a question on integration by parts. Okay, so you need to look at the formula given at the formula sheet, or if you want to remember my version of this formula, that is, if you have to integrate this u v dash, okay, so this is going to be u v minus u dash v dx. Okay, u is the one that you will be differentiating, that you know how to differentiate, and v dash is the one that you will be integrating. So when you have to decide that which one is going to be your u and which is going to be your v dash, so you see clearly this ln x cannot be your v dash because we don't know how to integrate it. So when you have to choose the u and the v dash, so u will have to be ln x. Okay, u will have to be ln x. Hmm. Oh, someone is pointing me to go back to the second question, and there they had ln a by 2. Let me see. I think you are getting too late to tell us about that. If I can really go back to that question, hmm, let me. Okay, so this was the question here. And yes, oh, there's a silly mistake in this question. This was ln a by 2. Someone, I always ask you to keep on checking your answer, because when I divided this 2 on both the sides, so this was ln a by 2. So we can do that correction here quickly. This was ln a by 2 over here, okay? So this is going to be, ln a is going to be, so this 2 goes here, this is going to be into 2, okay? So this is going to be 2 into this. Let's use the calculator now, okay? So this is 2 into, anyway, thank you very much for, it's never too late. It was there. Luckily, we hadn't gone so far away from this, okay? So this is shift ln of the answer. So that is 3.31. Okay. So this is, so there's a correction here. This is 3.31. Thank you very much, beta. So please, you guys, whenever I'm solving this, keep your marking scheme in front of you so that, you can keep on checking the answers. Okay, so we go back to the that question then. So this was clearly a silly mistake here. So these mistakes are really good for you people. You know how I'm making them, so you can avoid them. Okay. So going back to this, so this is, I just had written the formula here that the integral of uv dash is going to be uv minus the integral of u dash v dx. Okay, so your u is going to be ln x, and your v dash is going to be x raised to power 3 by 2. Okay, so now this u dash will be 1 over x, and this v would be x raised to power 3 over 2 plus 1, that is going to be 5 by 2. Okay, and over 5 by 2 will give us 2 by 5. Okay, so now let's use them and try to find this. Okay, for a moment, let me ignore the limits over here and focus on this integration here. Okay, so we have uv, that is going to be ln x. Put them into the brackets. Okay, this is really dangerous to write the things with the ln or the things with the sine, cos, tan without using the brackets. Okay, so you might mix them up. This is x raised to power 5 by 2 minus, now this is ln x derivative is 1 over x, and times this 2 by 5, x raised to power 5 by 2 dx. Okay, so now I can write it as 2 by 5x raised to power 5 by 2, and some simplification to be taken in account here. So this is 5 by 2 minus this power 1. So that is going to result in 3 by 2, I think. Yes. And now you can finally get it as 2 by 5. There was ln x as well here. I didn't write that ln x. Okay. There was an ln x here. Okay. So it's 2 by 5, x is to power 5 by 2 ln x, and then you have minus 2 by 5 into x is to power 5 by 2 into another 2 by 5. Okay. And now I can put the limits. Okay. Or maybe in the next step, um, let me clear this area. Okay. Oh, okay. So let me write it down now. So this is going to be the limit from 1 to 4, blah, blah, blah. That is, you have to write, by the way, all of this. Can I take 2 by 5 common from here, Hannah? And then this is 2 by 5. I'll keep this outside, and I'll keep this to x is per 5 by 2 common from here. And then into this, I have ln x, and then minus 2 by 5. है ना? This is minus 2 by 5 here. Okay. Now, please have a look at it very carefully. There should not be any careless mistake now. Please look at it, counter check this. So we have now this 2 by 5 into x raised to power 5 by 2 into 4 is, oh, this is going to be such a big power. Sorry, this is not x, this is 4. That is going to be 2 square raised to power 5 by 2 into this ln 4 minus 2 by 5. And then we have minus 1 raised to power anything is 1 into ln 1 is going to be 0, and then you have minus 2 by 5. Okay, so this results into 2 by 5 into this cancelled by this is going to be 32 into ln 4 minus 2 by 5, and then you have plus 2 by 5 from here. Someone please have a look at the answer before I finish this. Keep that answer in front of you, okay? So we have to write this as 2 by 5. You can use your calculators here if you want. This is going to be 32 ln 4 minus 62 over 5 plus 2 over 5. This is 2 over 5 into 32 ln 4, and if you take LCM at 10 minus 64 is minus 54 over 5. Now what's the answer? Please check that. Okay, we made a mistake here while simplifying these two mentally. I thought the LCM is 10, the LCM is 5, so this is minus 64 plus 2 will give you minus 62 over 5. And when you expand this, this is going to be 2 by 5, 32. And I write this ln 4 as ln 2 square, okay? So that 2 squares, like this is going to be 2 ln 2. This 4 is written as 2 square, so this 2 comes over here. So this 2 into 32 into 2 will give you 128 over 5 ln 2, and then this into this will give you minus 124 over 25. So finally your answer is 128 over 5 ln 2 minus 124 over 20 over 25. Okay, just a minute. Okay, fourth question. A curve has the equation y is equal to cos x sine 2x. Find the x coordinate of the stationary point in the interval this, giving your answer correct to three significant figures. Okay, guys. So we need to differentiate this first of all. Okay, I'm going to draw a line here so that my space is double. So so we have to be dealing with the stationary point. So one thing is in my mind that I have to put that dy by dx equal to 0. So this is going to be dy by dx, and this is clearly a product situation here. Your u is cos x and your v is sine 2x. So your u dash is going to be minus sine x, and v dash is going to be 2 cos 2x. Okay, so this is uv dash and then vu dash. Okay, so good to write the formulas, uv dash plus vu dash. Okay, so here we go. This gives us uv dash. So this is going to be 2 cos x cos 2x, and then plus vu dash. So you have minus sine x and then sine 2x. And we straight away put that equal to 0. Okay, we put that equal to 0. Okay, so now this is going to be 2 cos x. Now I have to start solving it. I need to keep all my terms in, like, first of all, there's a problem with the angle. There's x and then 2x. Okay. So this cos 2x can be written as, you can look it out from the formula sheet. This is going to be cos square x and then minus sine square x. Okay. And then you have minus sine x times 2 sine x cos x, that is equal to 0. Let's see, what do we get? So this is going to be 2 cos cube x, and then you have minus 2 cos x and sine square x, and then you have minus 2 sine square x and cos x equal to 0. Okay, if you look at this, yeah, 2 cos x is common throughout this equation, है ना? 2 cos x is common throughout. So let's take 2 cos x common from this. So this equation is a bit lightened, okay? So we have 2 cos x into cos square x minus sine square x, and then again minus sine square x. Okay, and that is equal to 0. Okay, fine. So now first thing we have with us, that is 2 cos x equal to 0. So within this interval we don't have any answer, because if this pi by 2 was included, then your x could be equal to pi by 2, but we don't have this option, so I'm not just going to ignore this. So we don't have any solution from this cos x equal to 0. Okay, now next is your this is going to be cos square x and then minus 2 sine square x. Okay, I have to be quick. There are just 2 minutes left. Okay, so we can change this with 1 minus sine square x minus 2 sine square x equal to 0. So 1 minus 3 sine square x equal to 0. Someone please look at the answer quickly. So you have 3 sine square x equal to 1, sine square x equal to 1 over 3. And again, there will be no use of writing the plus minus, because when you take the square root, this is going to be plus minus 1 over under root 3. And since you're still just within this first quadrant, so this sine x equal to minus 1 over under root 3 is useless. So we'll just keep it as sine x equal to 1 over under root 3. Please tell me quickly, what is sine inverse of this 1 over under root 3? Someone please be quick. Keep your calculator in radians mode. Okay. Here is this. Um, yes. Hmm. Shift sine of 1 divided by under root 3. That is 0.615. No one gave me the answer. I wonder what you people are doing there. Let's check the answer. This is question number, yeah, this is exactly the same answer. You can see here is the answer. This one is the answer here, 0.615. So we have the same answer here. So now we keep it up to this. Let's meet in the next session for some more questions from this paper.